Yeah, so there certainly is a historical track record of large satellites being extremely important for Earth monitoring. So the Landsat program, for example, runs for about 45 years, and it's captured an enormous amount of data about the Earth. But the Landsat system is also very expensive. An individual Landsat satellite costs several $100 million and has a number of people working to maintain it over time. So our approach has been to invest in smaller satellites so that we can take more pictures more rapidly. So Landsat revisits the same place on Earth, for example, about once every 16 days. And our satellites, once we have a full constellation, will be able to visit every day.
Ethiopia has become a very dynamic nation. Change is taking place every day. There is all kinds of development in every corner of the nation. There are mega projects in the lowlands. There are road constructions and demolition and reconstruction everywhere. So it's a day-to-day change that couldn't be addressed with the conventional satellite image over there. With a 16 days revisit time, we miss a lot.
So I'm Joe Mascaro, and I work on impact initiatives for Planet Labs. Planet is a San Francisco-based aerospace company that's built and launched 87 satellites into space since 2013. And our goal is in 2016 to have enough satellites that orbit the Earth that allows us to take a picture of every place on the land surface of the Earth every single day.
So when did it start?
The company was founded about 5 years ago. Yeah, there were three folks that founded it. They formerly worked at NASA Ames Research, doing things like small satellites. So they built satellites in a standardized cube form factor. It's 10 by 10 by 10 centimeters. And then they eventually started to iterate as the company grew into a 3U form factor, which is a larger satellite, but it's still just about this big. It's the size of a loaf of bread. And so it has solar panels attached to it and is able to take images and send them to Earth.
Are you planning to cover the whole globe with this small satellite?
Yeah, so we'll have enough in orbit that we'll be able to take pictures everywhere on the land surface every day. Our company, our engineers, and our team is able to innovate rapidly with hardware and software, and that enables us to not only construct more satellites that are smaller, that have incredible imaging power, but also iterate on those designs over time and improve them. So,
what is the spatial resolution, and can you tell us about the spectral characteristics?
Sure.
Of your products?
Yeah, so they'll image at about 3 to 5 meters per pixel spatial resolution. The spectral resolution, right now we're offering visible data in the red, green, and blue channels, but we're adding soon the near-infrared band.
Is it available for the public domain? How is it going to be available?
So Planet's a private company. So first of all, we have a number of customers, but we also have several partnerships. So for example, Planet has partnered with Meta Research on the Roads for Water program, in which we contribute data to the project to examine how roads could be used for water harvesting. Planet is also part of an organization called the Global Resilience Partnership that Meta belongs to as well, where we're working with several other teams supported by the Rockefeller Foundation, by USAID and CEDA, and we're providing data and technical assistance to all those teams. We're offering at the moment an Explorers program, which is an early access program. We're primarily interested in web developers because we're still a startup and we're still building our tools and our offerings. But we have a number of explorers that are using our data to explore how the API works and how the GUIs work, and give us feedback on the product.
What is your main target for application?
I think the options are enormous. Some immediate benefits that spring to mind include forestry, for example, the monitoring of deforestation and degradation around the world, particularly degradation because our pixels are small enough to see selective logging and events of that kind. And then when we get into things like water, for example, reservoir levels, we already see, for instance, today in California, we can see the lowering of water levels in reservoirs where we have a drought, and that's true around some other reservoirs around the world. So Yeah, those kinds of applications. I think really it's almost like a blue sky. A blue sky. We don't really know. You know.
So, what percent of the globe is covered by now? What's your future plan? How did you start and where you are now?
Right now, we have, for example, about 30 satellites in orbit, and we've imaged, I would say, about 40% of the globe. But the interesting thing is that we're ramping up the imaging quickly enough by getting the constellation into orbit that we should get to that daily imaging capability by around the end of next year.
What is the life of your satellites? Are they lasting long as compared to the bigger ones?
So this is interesting. I had to learn about this because I'm not an aerospace person. I'm a tropical ecologist, but the atmosphere is sort of puffed up, right?
Yeah.
And even in low Earth orbit, the satellites encounter drag in the atmosphere. And so we have satellites in a couple of different orbits, but the ones in space station orbit burn up after just about 18 months. Yeah, and they burn up completely. There's no hard parts.
So you have to replace those?
Yeah, so we have to constantly fill up the constellation. However, the satellites in the orbit that we're targeting to image the whole Earth, the sun-synchronous orbit, those could last as much as 5 years.
As an end user, I'm interested in your product. I'm very eager to see it being used at grassroots level, especially in the developing countries like ours, where we are lacking ground-based data, we are lacking researched data. Then this kind of products will definitely provide us with almost primary data, and the temporal resolution is just unbelievable. So to find this kind of data daily for a certain locality is an immense contribution to the globe, to the humanity really, and its global coverage makes it unique. You know? If it is continuing as promised, it's really a real asset. So does it have a humanitarian element in it, in this project?
Yeah, absolutely. So my role at Planet actually is to help with the team manage our social, humanitarian, and environmental impacts. And really, it's one of the funnest jobs at the company, although everybody, I think, has a pretty cool job. The company was founded to use space to help life on Earth. So it's really important to us. I think it's fundamental to the company to work on projects where we can help some of the world's most vulnerable people. So that includes places like the Horn of Africa, for example, in South and Southeast Asia, where we're facing crises of flooding and other forms of stress. So it's absolutely important, and it's one of our driving principles. I think we can't achieve that mission unless we work with the kind of organizations that are helping some of the world's most vulnerable people and taking on some of the world's most important environmental, social, and humanitarian challenges. So it's you could think of it as being in our marrow to partner with organizations like the Rockefeller Foundation, like USAID and CETA, and then Meta Research, for example. I think it's through those types of partnerships that we intend to have a major impact.
How can we benefit from this product to solve this the global food security problem, which is a big threat to come?
It's an enormous threat. I think the first thing is to do a better job of understanding agricultural production around the world. So in places, for example, like Ethiopia and Kenya, I think the kind of remote sensing assets that Planet can provide will improve our understanding of yields, planning of irrigation, for example, planning of infrastructure around the agricultural environment, and potentially, protecting the livelihoods of smallholder farms, which are much more important in Ethiopia and Kenya than they are in the United States, for example. And similarly, monitoring water levels when it comes to flooding as it interferes with agriculture in places like Bangladesh, in Vietnam. So those kinds of data sources, I think, are just fundamental to improving the agricultural landscape of the world.
I hope the spectral resolution of your product will also get improved soon. I hope we'll also enjoy the availability of more spectral band combination, and we can really benefit our poor community by using your products. And it's good that you focus in our region, where you can take it as a model. model of success. I'm sure it can be achieved.